Hello guys, so in this video we will continue our lesson with the gravitational force. Okay, so from what we have before is an equation for the Newton's universal law of gravitation, which is F. Okay, which is F. Let's write the equation. Okay, F equals to G, which is the constant, universal constant, M1, okay, the first mass, the mass for the first object, M2, the mass for the second object, divide by R square, where R is the distance between the center of the two objects. Okay, we have object A and object B. Okay, let's say object 1 and object 2, it has its own mass, which is M1 and M2, and there is a distance of R between the two center. Okay, then we can find the magnitude of the force between the two objects, magnitude of the gravitational force exactly between the two objects. Before we look further into our equation, okay, if you have your own textbook, you may open this page, and what they are trying to explain here, okay, to further understand how the mass and radius, or sorry, the distance between the two objects can affect the gravitational force. Okay, for the first diagram here, okay, for the first diagram, we have, okay, two phenomena. Okay, first we have object 1 and object 2. Okay, the mass are uh, the larger mass. Okay, the mass are smaller compared the second phenomena. Okay, second phenomena. So this one is 1, 2, and then 1 and 2. Okay. So let's say we have object 1 and object 2. Okay, object 1 and object 2. So maybe it has mass 1 and mass 2. Okay. So it will produce F1, where F1 is the gravitational force between them. Okay. So F1, okay, we will get M1 times M2 divided by R square, the distance between the two objects. Okay, the second phenomena, okay, we have, okay, let's change the number because at the above we have 1 and 2. Let's take 3 and 4. Okay, objects 3 and 4. So 3 and 4 has bigger mass, okay, has bigger mass compared to 1 and 2. So M3 and M4. Okay, so the masses for M3 and M4 is bigger than M1 and M2. That means the number, the magnitude of the mass is bigger compared to M1 and M2. And then it will produce gravitational force equals to F2. So F2 equals to G M1 and M3 and M4 divided by R square. Okay, that means the distance are equal. Okay, let's say this is 2 kilometer and this is also 2 kilometer. Okay, so in both phenomena, the distance are equal, but the difference are the masses of the object. Whether for the phenomena 1, okay, phenomena 1, masses are smaller compared to the masses in phenomena 2. So what can we get from this situation, from both situation? Okay, what can we conclude from both situation based on our equation here? Okay, remember, force, the gravitational force, is directly proportional to the product, okay, to the product of M1 and M2. That means if we have smaller number of M1, M2, okay, let's say we have 2 and 3. 2 and 3. So the product is 6. What we will get? We will get 6G over R square. Okay, 6G over R square. What happened, okay, with the same distance, R, okay, R, same distance, but larger mass, okay, much larger mass. Let's say we take as M3 is 20 and N4 is 30. So what will happen? So we will get G, so 20 times 30, okay, M3 times M4, divide by the distance, which is equal, okay, R square. So we will get 600 G divided by R square. So here you can see that although both situations have same distance between the two objects, but the masses of the objects are different, where for situation 2, the masses are bigger than situation 1. Okay, when the mass are bigger, it can produce a larger uh, gravitational force. So that's why if we compare ourselves with our friend, okay, around us, so why don't we feel the gravitational force if we compare ourselves with the with the with the earth, okay, with the surface of the earth. Okay, let's say here, let's say this is me, 60 kilogram, and my friend here, 60 kilogram. Okay, so why don't we feel the attraction force or the gravitational force between us compared to, okay, if we have, okay, this is me, 60 kilogram, and also earth. So what is the mass of earth? What is the mass of earth? Maybe much larger than this 6,000, maybe 6,000. So if we get the product of these two, 60 times 60, 60 times 60, and then we compare this one, 60 times 6,000. So this one, okay, this product will produce a much larger product, okay? So much larger product. Hence, the forces, the gravitational force is larger. Compare this one, okay? So clearly, the gravitational force is depends, okay, is depending on the product of mass, either M1 or M2. Okay, if M2 increase, so the product also will increase. M1 increase, product also will increase. Or both of them, M1 and M2 increase at the same time. And of course, the gravitational force will increase magnificently. Okay, so lagi besar. Okay, next we have other two situation. Okay, we have other two situation. Okay, so for the first situation, we compare the masses, same distance, but different masses. Okay, what happen if we have two situation? Okay, two situation. Okay, this is object 1, object 2. So M1 and M2, and then same object, meaning that we have same mass, M1 and M2. So M1 is 6 kilogram, and 2 is 3 kilogram. M1 is same kilogram, same mass, 6 kilogram, and 2 is 3 kilogram. Okay, the masses are the same. Okay, but the distance here, okay, but the distance here, let me draw. Okay, why doesn't it work? Okay, it does not work. Okay, it's okay. So let's say the distance here is larger compared to this one. Okay, let's say the distance here is 2 meter, and here is 20 meter. So what will happen? Okay, so let's look at the first situation. Okay, F equals to G, M1 and M2. Okay, so what is the product M1 and M2? M1 is 6 times 3, so 18. Okay, so this is 6, this is 3, divide by R square. R square, okay, let's substitute the number. So G, M1 is 6 times 3, we get 18, divide by R square. So R is 2, 2 square is 4. So we get 18 over 4 G. Okay. What will happen if the distance is increased drastically? So F, G, mass, okay, the product of mass is the same because 6 times 3 always 18. So 18. And then the distance here had been changed from 2 to 20 meter. 20 meter. So square, we will get 400. And then we will get uh, 18 over 400 G. Okay. So this is the gravitational force produced by the same mass but at a larger distance. Okay. And this one at the shorter distance. So here, what can we see that, okay, when we have a shorter distance, we can produce a larger gravitational force. Okay, when R decrease, the gravitational force will increase. Okay, that is what will be stated by the proportionality, inversely proportional. Okay, R decrease, F increase. And if the distance increase, okay, distance increase, what will happen to the gravitational force? Of course, gravitational will be weaker, will be less, will be decreasing. Okay, so that is how we can relate. Okay, what happen if we have same distance but different masses, or what will we have if we have same masses but different distance. Okay, that is how we investigate by using this equation. Okay, I think that's all for this session. So thank you.